All right, so today we're joined by Percy Liang, professor of computer science and statistics at Stanford, where he also directs the new Center for Research on Foundation Models. Percy, welcome to the Data Exchange podcast.
Thank you. Happy to be here.
And today we're going to talk mainly about your new framework for evaluating large language models called HELM, Holistic Evaluation of Large Language Models. And to start, a language model in the HELM sense is any model that takes text and outputs text, correct?
Yeah, that's right. It's a very simple object.
Yeah. So basically, we're recording this late December or early December 2022, where the rage in the popular tech press is ChatGPT. So that qualifies as a large language model in the context of this conversation, right?
Yeah, I mean, the interesting thing about a language model is that it's text in and text out, and it's been something that has been studied since Claude Shannon, many decades ago, and it's been used in NLP, in machine translation, speech recognition for a while, and it was useful. But it was only until very recently that it's taken on this new significance, because people realize that if you have a large enough language model that's based on a transformer neural network and trained on lots of data, you can actually prompt it to do various things that you might not have expected otherwise. So people use language models to essentially solve all sorts of different tasks, standard benchmarks, and more interestingly, new different type of scenarios. So one of the things that's hard about language models is that they're very simple, text in, text out, but the surface area of capabilities of what they're capable of is incredibly rich, and that's what makes evaluation hard.
Yeah, and this is key for our listeners. Is there's no singular large language model. In fact, if you go to the HELM site, they list roughly about 30. So imagine you're building an application, and for the sake of argument, let's say you actually have access to all 30 of them, and you want to choose which one of these to use. Traditionally, by the way, Percy, I'm actually I always find myself in this situation in a much more simpler scenario, which is what embedding should I use? So to start my NLP pipeline, and there's usually the current state of tools is here's a bunch of embeddings, but then you're on your own in terms of figuring out which one is best. So you have to do a lot of trial and error. And so imagine this situation, but in the large language model sense. And as best I can tell, what you folks have done is kind of take like a two-dimensional approach, right? So where you can kind of select what metric you want to evaluate on, or metrics, and then scenarios. Is that correct?
Yeah, let me try to kind of lay out what HELM is. So HELM stands for Holistic Evaluation of Language Models, and this is a new project it's really ongoing. We released the initial version about a month ago, but the idea is that for it to be a continuous kind of monitoring the state of language models, which is moving incredibly fast. Just the last month, there was Galactica, there's ChatGPT, of course, and the new OpenAI Text DaVinci 003, and I'm sure over the next month there will be more things. So one of the value propositions of HELM is to give everyone and who's a researcher, practitioner, policymaker, an idea of what's happening in this space from kind of a neutral, rigorous scientific objective. So as you said, Ben, we looked at 30 models across a number of different organizations, including OpenAI, of course, and AI21, Cohere, Google, Meta, Microsoft, and then some open models from Big Science. They just trained a Bloom model, models from Yandex and Xinhua, and so on. So it's a pretty comprehensive look, and there's some models that we didn't have access, for example, the DeepMind models and some of the other larger
what kind of access do you need to use to apply HELM?
So for this, API access.
Okay.
So text in, text out. you could ask for richer access to embeddings or the model weights, but we just require API access, which is sort of a lowest common denominator of sorts.
So in the language of traditional software engineering QA testing, so what are you doing? Is it unit testing?
You can think about it as that. So
Yeah.
you have this object language models, and we have 30 of them. And for each language model, you ask, how good is this language model? So how do you think about this problem when a language model is so general purpose? And the way we think about it is that there are scenarios in which this language model could be applied. So a scenario includes the task, whether it be summarization, question answering, text classification, and so on. And also the domain that it's applied in, which could be news, blogs,
Healthcare.
healthcare, finance. And that defines a scenario. And we have 42 different types of scenarios: summarization, sentiment analysis, text classification, and so on. And then we look at, in these scenarios, when a language model is applied, what do you care about? And traditionally, people look at one metric, which is accuracy usually. But we've found that accuracy doesn't capture everything that you might care about. And we look at 7 different types of metrics. So for example, there's beyond accuracy, there's calibration, which captures if the model outputs probabilities, whether these probabilities reflect the underlying confidence. So if you say there's a 70% chance of rain, is that actually 70% kind of meaningful or not? In other words, does the model know what it's going to know? Which is an important thing, because you see ChatGPT, it's confidently generating sentences that it doesn't know, have any idea about. So calibration is one thing. Robustness to different changes in a dialect. If you have typos or you lowercase it, do these models far apart or not?
Unicode.
Yeah, if you put it extra, sometimes you put extra space, it can cause.
I've talked to security people who purposely attack these models with all sorts of Unicode characters, right?
Yeah, so we've done some work in the past on adversarial attacks on language models, and most ML models are attackable in some form if they're complicated enough. There's also issues of fairness and bias. So these models are trained on the internet, but they're deployed. Do they perform equally well on different subpopulation, different demographic groups? And then whether they generate toxicity or not, which has been something that has caused problems.
So do you, so of the 30 models, let's say you have more access, I don't know, beyond API access to a model, it doesn't matter ultimately to the way HELM scores this model, right?
So if you have more access beyond the API, technically, no. I think we get more insight into why the results are the way they are if we have access to the model orchestration and training data. But we're trying to keep as standard of a interface as possible. And then the last metric is efficiency, and that actually does look at some information about the internals of the model, mostly how large it is. And so we have these 7 metrics, and the key idea is that there could be trade-offs between those. And for every scenario, let's say you're doing question answering on Wikipedia, you measure all of these metrics and you can look at it. So that's why, as you mentioned before, it's a 2-dimensional object. In fact, it's a 3-dimensional object because there's also the model dimension that we're looking at. So it's trying to be as systematic as possible. We standardize all the scenarios into one format, and we run everything.
Where does this whole area of detoxification toxicity come in? Is that part of what you do?
So we measure on generative tasks. So for example, summarization or dialogue, the ability of a model to generate toxic content. We're using the perspective API to detect whether there's something's toxic. I mean, Toxicity, I mean, I should say that toxicity classification is a very nebulous and always problematic and subjective thing. We're doing our best based on what exists, but this is a whole research area on how you even define toxicity, and it's very contextual.
So do you so for each model that you have these 2 or 3 dimensions, you score them across all?
Yeah, we score them all
combinations?
across all of the
I
different
see.
dimensions. Yeah.
Yeah. And how long does it take to score one model comprehensively? I guess it depends on the model size, right?
Depends on the model. So some of the largest models we looked at is Microsoft and NVIDIA. They had a 530 billion parameter model. That takes quite some time. Some of the smaller models are only 6 billion parameters, so they're less time.
And your tests tend to be very English centric.
Yeah, so that's a good point. So all of the scenarios are English only for now. One thing that we do in this benchmark, if you go to the website, which is crfm.stanford.edu/helm, is we explicitly mark the things that are missing from the benchmark. And I think this is important. Again, I think the main takeaway is that language models are so vast and so broad that even conceiving of the space of possible scenarios is difficult. So we're doing our best. We taxonomize the space. We say, here are the things that we are able to measure, and here are the things that we don't do. So for example, we don't have multilinguality. That's measured. There's models that we're also missing. We don't have deep minds models. We don't have Palm, for example. There's some other models like Galactica from Meta that just came out, which we're going to evaluate, but we haven't had a chance to do that yet. So the idea is to be sort of very upfront about what we cover and what we don't, because a lot of benchmarks, which could be very comprehensive, but they only list the things that exist. And I think one thing that we want to do is set up a scenario where there's this kind of aspiration of what are the use cases that we really want to look at, especially since the set of use cases is constantly evolving. For example, people are using language models for maybe customer service or education or story generation or copywriting.
Or writing code.
Yeah, writing code. We have some code stuff, but we could have more.
So Percy, how would you, so if you're a practitioner, if you're in industry listening to this, the best use of Helm is more as a filter. So for example, start out with 30, go to the Helm website, look at the different scenarios and metrics, and then maybe you can narrow down to your top 3 or 4. Is that?
Yeah, the way I would use Helm is to look at the scenarios that you might care about. So if you don't care about generation, then you don't have to look at those, but maybe you care about classification. You can go to the scenarios, and then there's tables that tell you the ranking of the models. One thing I think is special about Helm is that not only do you get the tables of the accuracies, but if you click through, you can look at the predictions of all of the models on the data set. And you can judge for yourself whether this type of behavior model behavior is something that would be useful or acceptable in your given domain. So the philosophy is trying to be fully transparent about what all of these models are doing. And I think one of the things that companies and might be interested in if you're doing a small project or something is, well, should I use OpenAI's API? Or should I use an open model? Maybe I should just download OPT, or I guess OPT is maybe research only, but GPT-J.
But whatever you do, ultimately you have to try it on your use case on your data. But at least you can narrow down.
You have a reference point, and the goal is as we expand the number of scenarios, there will be use cases which are sort of representing the things that you might care about, and And in that case, it's more or less more search. We're trying to make it so it's easier for people to figure out if they want a language model to do X, what is the best one to do at? How well does it work?
So how will Helm get updated moving forward? Do people just file pull requests? And
yeah, so it's open source. Everything's open source. If people have interesting scenarios, especially if you have your particular data, of course everything's open, so no private sensitive data. But if you have data sets that you're interested in, maybe unique scenarios that aren't being represented, we love to get contributions, and if they get added to the Helm benchmark, then we're basically running these data sets on all the models. And I hope that this will be a community effort where we build up this as we add new models, new metrics, new scenarios, and gradually fleshing out the whole evaluation space.
So what metrics are you thinking of adding?
So one major thing is generation is extremely hard to evaluate. So we have summarization, and which we
by the way,
actually
summarization is what's the metric? It's subjective.
Right. Not only is it it's subjective, but also it turns out that the automatic metrics are extremely bad.
It's focus group. You need a focus group.
Yeah. So there's so there's automatic metrics like Rouge. We show that they're actually pretty bad with respect to these data sets. So there's problems with the data sets as well. And we look at human evaluation, which is some more generic, like how good is this summary. We look at many metrics like faithfulness. Does this summary lie? Does or not? Is it point out all the salient effects? So there's not one metric, but it's a set of different metrics that capture different aspects of the important. But I think to your point, if your summarization for a particular purpose, if you have a goal in mind, is now that looks more like maybe question answering almost. But that's something that would be interesting to get at as well. But the general point is that human evaluation is needed for some of these interesting generation cases. We also have a follow-up work.
So wait, so how are you gonna? So you need human evaluation.
Yeah, we need
then, so then how are you gonna implement? What's the implementation for the generation?
Implementation is you run the model, you get some text, and then we launch some tasks on Mechanical Turk.
Like Mechanical Turk.
Yeah. So we did that for, obviously it doesn't scale extremely well. So I think this general strategy would be to do evaluation only on the top models.
Hey, can you have a language model evaluate another language model summary?
Yeah. So we can do things like that as well.
Yeah.
So some of the generation evaluation is actually model based. So based on not like the same model, but a different model.
Like a GAN for language model.
So yeah, I mean, another way to think about it is you can do self-consistency. If you prompt a language model with here is generation, have it assess itself. I think there's a ton of things that we can.
And this is a huge area right now, the generation, right?
I think one of the reasons that these language models are so exciting is that for the first time, you can actually generate large coherent paragraphs. There's also images, which actually we're thinking about moving into that space as well, but that's going to be another huge can of worms.
So has the NLP research community kind of settled on what's the threshold before you call something large?
I've actually stopped saying the word large language models. I just say language model.
Yeah.
Right, because to your point, what's large? Is 1 billion large? Is 100 billion large? It's also going to shift over time, and also size isn't the only thing that matters. So it's really, I think this obsession with large comes from just the initial push of scaling and realizing that this leads to different capabilities. But what I like to focus attention on is what these capabilities are, and size, if anything, should be in the denominator. Like if I have a 1 billion parameter model that's just as good as Text Da Vinci, OpenAI's model, then we should celebrate.
Although your initial findings for Helm, the size seems to matter for fairness and accuracy, right?
So it's a little bit more complicated than that. I think within a model family, size
Within a
matters.
model family, yeah.
Within
the model family.
Within coherent models, increase the model size helps, but not across model families. So and the Turing model is 530 billion parameter model. It's about the same level of performance as the Anthropic 50 billion parameter models, which is 10 times smaller, right? And this has to do with instruction tuning and reinforcement learning from human feedback or whatever is going on behind the scenes. So it's a combination of data and scale, and ideally you have both. But sometimes if you don't have the scale, you can make it up for having better data.
One of the things that you guys found, which I found reassuring, is that these models don't seem to violate copyright.
So I think I would probably not say it as a kind of a blanket statement like that.
Yeah.
Of the scenarios that we looked at, I think on average, we didn't find significant copyright violations, but we actually have some follow-up work on this, but it's definitely the case that these models memorize things, and especially if a piece of code or text appears multiple times on the internet, you can get the model to spit these things out, right? I think what we're
but long sequences, like a whole sentence or whole paragraph, unlikely, right?
It really depends on the particular setting. I think in our setting, we just sampled a bunch of random. So if you're looking at just like your average paragraph, you just sample a random paragraph, can the model generate it? Maybe not as well. But a popular paragraph, like the first paragraph of Harry Potter, certainly you can do that. The other thing I think is important to note is that copyright is a much more complex issue than what we're looking at. We were looking at edit distance or very superficial metrics, right? So copyright can apply to, for example, even using the same characters, and sort of there's a sort of essence of a work that gets copyrighted, and if you change all the words, that still violates copyright, right? So imagine, for example, translating a document into another language, still copyright violation, even though none of the words are the same. So I think that's another thing that we need to develop more. And the copyright is, I think, an especially important area to look at, given the fact that now there's lawsuits flying around about this stuff.
So given that US and China are the two AI superpowers, the other family of large language or language models that are quite good are focused on Mandarin, right?
Well, we only evaluated one model from China, which is GLM. That's another interesting area to look into. I don't have too much visibility about the large language model space over there. There are, sometimes you see papers like Wu Dao has.
They announced this ginormous models too, right?
Yeah, they have ginormous models, but again, size isn't the only thing unless you do like the evals in a systematic way. It's unclear, and also evaluation is extremely tricky now because of train test contamination. If your test set goes into your training set, you will definitely get very high scores. Even if not just like your test that goes in, like we have try to be as careful as possible with our metrics. We say that we mark something as possibly lightly contaminated, even if the training split of a data set is in the pre-training corpus, because what we're trying to measure is essentially a few shot learning. And if you see 10,000 examples of question answering from squad, then you're not measuring few shot learning anymore. So
So-
I think the evaluation, if you don't know the data set, is extremely challenging.
So is this statement more or less not accurate, but kind of accurate in spirit? The best public models are worse than the private models.
So right now, this seems to be the case as a snapshot in time. So OpenAI and Anthropic have better models than I think the best open models are like OPT. But if you think about it, another way to think about it is that 2 years ago, it was the difference between like the best public model was like T5, which was 11 from Google, which is 10, 11 billion parameters, and so I think the gap has definitely shrunk in terms of, at least at this point in time, with OPT and Meta. And in general, there's more people training these models. Before, like 2 years ago, it was only really OpenAI and maybe Google that were doing it, and now there's many players, including some of them from companies who are producing open models like Meta, but also startups. Many startups are training their own. So I think that part is good. I think it will be interesting to see what happens in the new year. Certainly, OpenAI is not sitting around. They have GPT-4 or whatever model that's gonna come out, and it's probably gonna be quite a bit better. But at the same time, I think there's a encouraging amount of enthusiasm from more, let's say, call it the open source, open models community that's trying to build open versions of these models. And,
So can you elaborate on the metrics that pertain to efficiency?
Yeah. So on efficiency, let's talk about inference efficiency.
Mm-hmm.
So the simplest thing you can do is you hit the API and you just measure wall clock time. How long did it take for me to get a result back? And this is a useful thing to know, because if you want to use the API, you kind of want to know.
Depends on the hardware they have back
Yeah.
then.
So on one hand, it's some people would care about. Depends on what you're interested in.
Yeah.
So if you're an end user, that's kind of what you care about.
Yeah.
But it's not really about the model. It's about model plus hardware, as you were saying.
Right.
So then we do this other thing where in cases where we have the information about the model architecture, we run this architecture on a sort of a normalized hardware, like a bunch of A100, and then we measure the latency on that. And that offers a more controlled comparison. But of course, that's sort of all about the model. And the other ones are end-to-end. And I think there are interesting things in between. For example, you might imagine people doing something clever with caching or batching that fundamentally does improve inference efficiency. So what's in between is a mixture of hardware and optimizations, right? So it really depends on what you're trying to measure. So there's a model efficiency where it's only probably a model. There's optimizations like caching and batching and various tricks. And then there's hardware. Like if you add more GPUs, sure. In many cases, you can get things to go faster.
So at least for 2023, this trend towards bigger is better may still pay off. In which case, are we gonna run out of data? Because where are they gonna get the data?
So just to clarify on bigger, there's more compute and there's more parameters, and those are different. Right?
More parameters generally, right? So
like DeepMind had a paper where they released Chinchilla, which is another model, showing that with a 70 billion parameter model, if you just train on more data for longer, you can actually outperform bigger models like their Gopher model, which is 280.
Oh, so in that case, actually, you might be able to get by with even less if you hook it up to like a knowledge base, like Google Knowledge Graph.
Well, so this is interesting. So we've been talking mostly about language models as a self-contained unit. If you give language models ability to retrieve documents or in general do tool use like access calculators and knowledge graphs and all that other stuff, then you're vastly expanding the capabilities of these models. And I think in some ways that's the right way to go about it, because even as humans, we write things down. We use the internet to search.
Plus, it might be a curated set of facts, right? So
yeah. So I think that, but from Helm's perspective, that's just part of the system.
Mm-hmm.
The system. That's another beauty of having it be API based, because we just feed you in text. The model figures out how to do it. Maybe it needs to retrieve documents, maybe it needs to do something, and then it outputs the answer, right? So there's nothing about our benchmark that says it has to be, it's aside from the efficiency metrics, that says it has to be a transformer or it has to be trained in a certain way. It's sort of just like a natural language interface that we're evaluating.
But it's fair to say that GPT-4 or whatever the next number is will be bigger than GPT-3, likely.
Probably. I think there's many rumors on the internet about what it is and what it isn't. I think no one can say for sure. But again, size is, I think, hard. I'm sure that it's more compute in terms of size. Depends on how you measure. If, for example, if it incorporates sparsity, then it might have many more parameters, but the actual inference complexity is going to be smaller.
What about so is data still kind of a moat?
Data is very important. I think it's a good question. I think that certainly there's a lot of mileage that you get from doing instruction tuning. Both OpenAI and Anthropic have been doing that. And presumably there's a lot of value in the data that's curated. The papers themselves don't actually use that much data. So anyone, I think, could just go collect that. But presumably that's been scaled up, or if you scale that up, at least, you start to, get, higher quality models. It's hard for me to believe that data won't be like some sort of, moat. I think with the rise of foundation models, it's less of a moat. It has been less of a moat because everyone has access to Common Crawl, right? But
Common Crawl, Percy, is once every 6 months. Google indexes the entire internet in minutes. Every few minutes, they refresh their index.
Yeah, so there's effort. I mean, there's efforts to try to. I think Hugging Face has a project where they're trying to build a new model, refresh it based on new web updates. But I think what you're trying to get at is, I mean, there's new text generated every second, and you could imagine another architecture that's about ingesting that data in a more continual learning fashion.
And also there's data, there's metadata, there's usage data. So usage data would be in the Google sense, they know what people click on, what headlines, what ads they click on, and then metadata, these backlinks, right? Yeah.
Well, certainly, if you think about the mode in any given application, such as if you're in search or you have, recommendation system that you have, billions of clicks on, that's probably valuable information, especially if you have data on particular users that isn't just going to be replaced by a language model. But I do think that the promise of these models is to give you general purpose language abilities and reasoning and knowledge, right? So it definitely alleviates some of the it reduces the amount of data you will need in your given domain.
Yeah.
And
So speaking of which, where are we in terms of tools for fine tuning? So in other words, I take one of these general purpose language models
mhm.
and I want to fine tune it for some narrow area, let's say in oncology or radiology, very specific. How much data do I need to do that fine tuning?
For fine tuning, I don't think you need a lot. There's maybe two levels of fine tuning. One is that you have unlabeled data in radiology or oncology or biomedical data in general. And you just essentially doing continued pre-training. Like, yeah, you can train that for a bit of time. And then there's a fine tuning where you have a data set of like you want to do a particular task. And usually those are
like named entity recognition, for example, right? So,
yeah.
But
yeah, I mean, I think a lot of these things, you'd be surprised how far you can get with just the vanilla model and
a few hundred examples.
Yeah, and or even in some cases maybe very few, maybe like 5 samples. Depends on the task, of course. Like these models have seen a lot of data. Yeah.
So we define language models as essentially text in, text out. So what's a foundation model? By the way, before you start, some people don't like the term, right? So
yeah, that is true. So a foundation model is a term that we created about a year and a half ago, and it captures a broader category, includes language models, but also includes vision models and other modalities. Right? Language models are about language, but there's more than language. And the reason
so is it right now a foundation model tends to be modal specific?
Well, the general idea of a foundation model is that it serves as a foundation. It's a model that's trained on broad data, and then it can be adapted to a wide range of downstream tasks. And this could be in any different modality. So I think the paradigm shift that we saw is that with things like BERT and GPT-3 is that you have one model that you invest a huge amount of infrastructure in building, and that model helps you with all the different downstream tasks, as opposed to the previous paradigm where you start by you collect a data set and you train from scratch. Maybe you include word vector features or something, but that's more of an afterthought. Whereas a foundation model says, no, you start with this foundation and you improve it over time.
And it's just that right now, the current state of the art is they tend to be tied to a type of data. So there's a foundation model for text. There's might be Whisper for speech. There might be something else for vision.
It could be tied to data. It could not be. There's multimodal models like Flamingo or CM3 from Meta, or even I guess Stable Diffusion or DALL-E or other types of foundation models. And I think the point,
So it's basically anything that becomes the starting point for your pipeline.
Yeah. I mean, I think it's really kind of what we're trying to get at is a shift in the way that models are built. If you look at, let's say, well, there are many examples, but let's say T5, right? T5 rose to T0, which then got extended, and OpenAI, you started with GPT-3, and then it got you added code, and then you add some other data, and then you improve it to make ChatGPT. So there's this kind of more incremental process that happens. Just like Colin Raffel has this great post on these models like open source software. They get derived. You clone a fork of repo, and then you improve it, and maybe you merge it back.
But kind of by definition, they're like horizontal platforms, and then you can kind of build vertical applications on top. So because they're horizontal, by definition, only a few teams will build these things.
There were definitely a much fewer number of foundation models and applications, because otherwise it wouldn't be
Yeah.
foundation.
And then
But
they become harder to build. So then there's going to be just a few teams that will end up building these, right? So the usual suspects.
well, that's yeah, I mean, so certainly that's the way things are trending, but I think it's still early to tell. I think the open source ecosystem may produce artifacts that make it possible for many more players. Certainly, different countries might, Europe has only, they're going to build their foundation models. We already talked about China. Korea has a foundation model. So there's going to be different regional differences. And also in different domains where if you have private data, if you think about the amount of private data that there's way more private data than probably useful public data, and you can imagine companies which are internally building foundation models that are trained on private data, right? So there's probably the total number of foundation models is not going to be like, it's not going to be like 5.
But the foundation models of these private companies probably still use the foundation models outside. You know what I mean? Because
well, so,
like let's say you're like
yeah.
Goldman Sachs or something, right? So I mean,
you're
probably going to rely on GPT-10. Then you build kind of a finance on top of it, right?
Yeah, it's unclear to me, because I think if there's only API access, that's not enough to build. If you, I mean, it depends on how technical, how much a company wants to invest, and how much data they have, and whether they are comfortable shipping that data to OpenAI or someone else.
Right.
So I think there's many more barriers to. I don't think there's just be like one GPT model that rules them all. I think that's I think the dynamics of how organizations are structured and trust and cost and other things will make it so that it's unclear. I mean, I think it's too early to tell.
Right. So this is kind of like, in many ways, kind of like on-prem versus cloud.
In some ways, I mean, with the difference that these models can be fine-tuned. So in some cases, you might imagine.
I mean, private cloud versus public cloud.
Yeah.
Right. So
the other thing is, I mean, I think these models are opaque, right? And if you get a foundation model from someone, you actually have no idea how it was built, what kind of properties.
That's why we're relying on HELM.
We tried. I think HELM will help, but even so, I think just to give you some other cases, there are, not to mention kind of copyright issues, but there's, I think, security issues. For example, data poisoning is an attack that an adversary can inject data into a training set of a model and cause it to do whatever the adversary wants. Normally, this is not that big of a deal, because as long as you don't let people access your training data. But in now, the training data is the internet, so everyone can access your training data in some sense. And this is a huge security vulnerability.
Or it could be like kind of a Microsoft Day moment for, inside one of these large models, right?
Yeah, I mean, researchers have shown that you can put backdoors behind. You put some piece of data on the internet, it gets trained on, and now you can kind of trigger that at any moment in time. So I think there are. So that I think is a general problem that we're going to have to grapple with. At least with open source code, you can in principle read it, but now we're dealing with these models that might appear to be working fine, but may have, catastrophic failure modes in certain, different regimes. So again, going back to your earlier point about data, yeah, data is extremely important, especially in the context of adversaries.
There's also kind of the dependency risk. So the other day, actually, I was looking at the list of models on Helm,
Yeah.
and I imagined the scenario where, let's say, I bet the farm on GPT-3, and for some reason, OpenAI cuts me off.
Yeah.
The number of options isn't that many. I mean, which of these am I 100% confident will allow me to continue using their model, right?
Yeah. And a lot of players are, hedging their bets. Maybe they'll use OpenAI or Cohere or AI21. So that spreads the risk around. So of course, as usual, competition is a good thing. But even still, like having your business kind of depend on dependencies are always problematic, right? Because the pricing can change,
Exactly.
availability can change, and maybe often you want to do things that maybe the API doesn't support, and so on. So, and
what about this kind of, Percy, this hybrid scenario we discussed earlier, where you take one of these language models, you pair it with a knowledge base or something else, and then the models don't have to be that big, but you still have to have access to the different components, piece them together in a performant way, right? So,
yeah, I think externalizing some of the knowledge can definitely help. I still think that a lot of the capabilities that you see in, let's say GPT-3 cannot just be externalized to a knowledge base. If you look at the number of skills solving word problems or generating, speeches or writing code, each of these does require some amount of kind of online or inline knowledge. It's not just like looking stuff up. Like sure, for factual things, you can look things up. But I think one thing that we've been interested in is to see how small you can make these models if you were able to externalize some knowledge. But even for knowledge, I think if you train on, let's say, a lot of biomedical data, you might be able to learn patterns and abstractions that go beyond any individual document. So the problem with doing an internet search is that you find a term and you look at it, you retrieve it, and if what you want is located in a web page, then that's fine. But for general trends, that's not located anywhere. And abstractions that's not located anywhere. It's really the aggregation of all the individual pieces. And for that, you still need to train a reasonable language model.
So in closing, what's the expected cadence for Helm in terms of updates?
We're trying to go as fast as we can in terms of keeping up with models.
So let's say GPT-4 comes out tomorrow.
Yeah, we'll get on. I mean, part of it's like getting access to it. But just to give you a heads up, so AI21 and Cohere had new models that are coming out. Actually, just came out. We benchmarked them. We're benchmarking the new DaVinci 003 model from OpenAI. We're looking at ChatGPT. It's a little bit tricky to benchmark. There's a few other models we're going to benchmark. So we're hoping to have an update, before the
Percy, is Helm always going to be Stanford based, or do you envision it to become much more like a industry or kind of a more beyond Stanford?
Yeah, I hope it will grow to be much more. This is not about Stanford. This is about the community understanding the capabilities and limitations of language models. So maybe an analogy is like MLPerf.
MLPerf, yeah. That's what I was thinking of, right? So it started out at Stanford and then it grew out, right?
Yeah, exactly. So for now, we're trying to just get it off the ground and trying to do what we can. But the hope is that it gets adopted. It's useful for people, and there's many people that would be interested in contributing.
Actually, I have one last question, which is on the Center for Foundation Models.
Yeah.
So broadly speaking, is the area of focus building foundation models, testing and evaluating foundation models, or what?
Yeah, it's all of the above, right? So that we created a center because we wanted to do something unique in the foundation models. This was clear that foundation models was going to be a big deal. It was clear a year and a half ago. It's even clearer now. And I would say that you can think about the mission as to provide transparency and understanding of the space. And HELM is a prime example. We're doing systematic evaluation of the language models. Hopefully we'll do vision models as well. Even the report last year that we put out tries to conceptually lay out the space of possible risks and opportunities in foundation models. We are doing a bunch of studies to try to understand how these models work, why are they so effective, and so on, and what aspects of the data contribute to model behavior, and a bunch of scientific questions. There are also other things that, for example, Chris Ray's group is actually doing a lot of cool stuff on building different architectures that hope to be better than transformers. And there's also systems level improvements like flash attention that make training go 2 to 3 times faster. So a lot of kind of innovations on the technical side. There's also, I guess, this is part of HELM is also to think about the societal impact of this. We have I didn't mention this, but there's some studies on the risks of disinformation in HELM, where we have it generate disinformation. We get humans to evaluate disinformation, and we're talking about copyright. One of the things that is unique about the center is that there are not just computer scientists, but legal scholars, economists, political scientists, who are all interested in what is happening with this technology and what kind of implications on society there will be. So that is one thing. Another thing, to your point about training models, I think we're training models. We're not going to train and compete with OpenAI and GPT-4, but the reason we're training models is you need to train to understand how they work. Machine learning is a process by which you take data and you turn it into
empirical. Yeah.
And you can't just take an existing model and fully really understand how these models work. So we're training with different types of ablation, more with a scientific eye. Another class of things we're training is models which are sort of unique in some way. So we have a model that we're releasing soon trained on PubMed articles, which is like a 2.7 billion parameter model, so not large in the grand scheme of things, but it's a lot larger than many of the existing medical models. We're trying to train a model on music as well, a model on legal text. Apparently lawyers write a lot, so there's a lot of data in that regime. We have a project on trying to leverage the clinical data from the hospital, training private foundation models. So there's a bunch of interesting applications, I think, that foundation models points out, and that involves training on these unique data sources.
And with that, thank you, Percy.
Yeah, thanks, Ben.